Here is an example in which we are using a distance-based measure to calculate or to form a cluster. So in clustering problem, we usually have a set of data which is being distributed in a similar fashion like shown in this figure. So our objective is to convert this figure or this data to similar kind of pattern here, right? So in this figure you can see that we have basically created different clusters or different groups of some data points, and these groups are basically formed on the basis of some measures, and here we are using a distance measure in order to form these groups. So even in, you can see through observation, like these data points have the minimum distance to each other. So on the basis of minimum distance criteria, we formed one group of these points. So we have one group or cluster here. Similarly, these points are closer to each other and these points are closer to each other, so we can make two different clusters from these different data points. So in total, out of these different sets of data points, we can create almost 5 clusters, and all these clusters are being formed on the basis of distance between different data points. So those data points which have minimum or closer to each other, they can be formed into one group or cluster, and in this way we can have in total 5 clusters. This way easy, but how do we know that we need to form 4 clusters, or we need to form 5 clusters, or we need to form 2 clusters, right? Because in this case, another choice for me was to make a cluster. For these data points I could make only one cluster, right? Or maybe for these data points I could make one cluster, right? So in this case, these 5 clusters will be reduced to 4 clusters as shown in this figure, right? So you can see in this figure that we have make one big cluster of these two different sets of data, right? And then 3 small clusters for these 3 classes. Another configuration can be to form a cluster of these two groups, so we can have a one big cluster here and we can have small 3 clusters like this here. And another possibility is that we can have a cluster of these data points here, and then the rest of the clusters can come like this way, and in total we can form 4 clusters. So here are some possibilities which I have shown to give you an overall idea of making clustering and to decide that how many clusters we want to make, right? So we will see in detail that how basically we are creating these clusters and how we can decide that how many clusters do I want to have for my initial data distribution. So the goal of clustering is to determine the intrinsic grouping in a set of unlabeled data. So now you will be much more clear after seeing the figure which I showed you in previous slide, that the goal of or the target of the clustering is to form intrinsic grouping of the different data points, and those data points don't have any pre-labeled class or a target value, and that's why we have these sets of data as an unlabeled data. So but how do we decide what constitutes a good clustering? So it's a measure that we will be seeing, that how we decide that we have performed a good clustering or a bad clustering. It can be shown that there is no absolute best criteria which would be independent of the final aim of the clustering, right? So you have seen that we have different ways and different mechanisms through which we can make different clusters. So there is no absolute best criteria which we can say that can help in the final aim of the clustering. Consequently, it is the user which must supply this criteria to suit the application. So it is a user dependent thing that how much the value is being set for the number of clusters. So for example, if the total number of clusters is being represented by k, so this k will become a coefficient or a hyperparameter for the k-means clustering algorithm, and the number of clusters that will be formed after the clustering algorithm will be dependent on the value of k. So if the value of k is 2, then the algorithm will form 2 clusters. If the value is 3 or 4, then the algorithm will be forming 3 or 4 clusters. So some possible applications of clustering where we usually use these clustering algorithms is to, for example, if I want to reduce data or data reduction, or for example, if we have a large set of data, and this data, or we have, let's suppose we have small large size of features which are being extracted from our data set, and most of those features are basically similar to each other, right? And if I want to train my algorithm on those features, then my algorithm will take much more time if I train them on much higher or bigger feature set which are even similar to each other. And since they are similar to each other, therefore they will not be playing any important role in the overall accuracy of the system, but they will be increasing the training time of my system, because then the feature set is high, so that's why the training time will be higher. But since most of those features are similar to each other, so that's why they will not be playing much important role in the overall classification. So it's better to remove those features which are similar to each other, and it's good to have only those features which have high variance in them, so that we could reduce our overall training time, and we could improve the performance on the other hand. And for this purpose, we can use a data reduction technique, and that data reduction technique will be based on a clustering algorithm in which we will reduce the size of the data that is homogeneous or that is similar to each other. So that can be one application of a clustering algorithm. Another application can be to find natural clusters and describe their unknown properties, right? For example, if we have different data sets which belongs to different properties or attributes, and we are not familiar with those properties, and then what we can do is we can apply a clustering algorithm on those points or data sets, and our clustering algorithm will basically group them on the basis of their properties. And then instead of manually selecting or grouping different objects with different properties, we are basically clustering them together, so the elements with the known properties or the same properties will be grouped in a single cluster, and other objects with other properties will be grouped in other clusters. So it will help us to understand different properties of different elements. Another application of clustering is to find useful and suitable groupings, right? So related to any application in which I need to form groups, I can have clustering to find useful and suitable groupings. And another thing is that I can use it to find unusual data objects, for example, outlier detection, right? So in most of the applications, or in most of the real life situations and problems, we normally face this outliers things, right? So outliers can be caused due to data acquisition, or maybe during data transmission. So it is possible that a noise can be added into the system during the transmission of data, or maybe during the acquisition of data, and that noise will basically be acting as an outlier in our whole sample of the data set. So in order to detect those outliers in the data set, it is common to use clustering algorithms for outlier detection. So once the outliers have been detected from the data set, then we can easily discard them or remove them from our data set, so we can have a cleaner data set. So clustering is also helping us in order to clean the data set that is being used for by different algorithms for different applications.